My math interest project is how does baseball have to do with geometry? So I'm going to be looking at four different things: the field, the strike zone, the size of the baseball, and foul balls. Actually, because they have to do geometry. So it looks like they actually just got a new pitcher. So first we can focus on the strike zone. Can't really see it yet, but so for now, you can look at the count. It's 2-1. So that means there's two strikes and one ball. So the two strikes represent what went in the strike zone. So and also if you swung, which is strange, but so technically, if a ball goes into this little box that's around, like right where the catcher's standing. Like it just kind of went in and he swung, so that's what you're supposed to do. So if it goes in and you don't swing, that's a strike. So a lot of the pitches are in, so that helps because the strike zone helps because, as you can see, a lot of balls are thrown at it, and so like if they needed to keep track, because like unorganized baseball, when they don't have something like this, it says like it doesn't say what's happening and where. So like if you didn't have this, then if it went outside, some people might still say that it's inside, and that would still count as a strike, which you don't want. So this is no, that's not it. All right. So now there's an out for Russell. Who's up? Elmore is up. So we can wait for him. So 0-0, because when there's a new batter, no one actually throws the pitches yet, and they restart it. But that, because the strike zone is empty, there's nothing at it. So you can wait to see what happens with it. So outside, did he swing? Yeah, he must have swung, because that still counts as a strike. But it was still outside, so if he didn't swing, it would have been a ball. So that's pretty much how the strike zone works and how it has to do with geometry, because it's a certain size. So if it was a different size, like say it was a little smaller with that pitch just now, it would have been considered a ball. So it needs to remain the same size. And from some of my research, I saw that it's different size compared to the different heights of people. So that's pretty much that. And so here, perfect to hit. This is how the field works. So you see those lines right there along the bases. So that is called baseline. So that helps the runner understand what you have to run and how. So technically, the baselines are connected to the bases. You need to run the bases to try to get to home plate to score a run, or a home run, which is different. But when you run around the bases, you need to stay outside of the baselines, because if you don't, you could be swerving all over that area if you're going to first base, which you can't really see, but yeah, where the person is hitting it. And that's the baseline, because the field is shaped like a diamond. And hold a home run again. That's a home run. Just saying. Here, let's replay it. Oh, they're not gonna replay it? Never mind. Alright. Oh no, that was well, so actually I thought that was a home run, which fools me a lot. That was a foul ball, which was one of the things I was gonna talk about. So Kyle Schwarber, he hit the ball, but it went high, like it was actually, if you saw it, it was like in the sky completely. But it was not. It must have gone behind him, or still behind the baseline, where it didn't count because it wasn't inside the baseline, which it has to do with baselines too. But I still consider that geometry because of the field. If you hit the ball somewhere, it counts as a foul or a home run, which is a big difference because a foul is a strike and a home run is, big. Scores a point. So the second thing that I'm not going to really be able to show, but the speed of the ball has to do with geometry too, like because of the shape. So a baseball is here. I have a baseball. A baseball is pretty small. It's not super small. If a baseball was bigger, then it would. If a baseball is bigger, then it would have more size. So let's see. A basketball. If this were to be used in baseball, it would go much slower. And let's see what else I have. If a tennis ball was used in baseball, it would go a lot faster. Now, a lot of my baseballs are not here, but let's just shorten this size a little bit. This is about a good size of a baseball. That's not. So that's technically why. So this tiny size, I were to throw it, let's see. So I'm going to throw it right here on the wall. It's going to go pretty fast. All right. You didn't even see it that well. See? Now I'm going to throw this at the wall, which is going to hurt. Okay. So, I can't really throw it at the wall because it's not good, but, you would definitely see passing by and then going back, which makes it much slower. Because if you don't see it, then it must be going really fast. But if you see it, then it must be going slower. So the other one, which I lost, it goes about a good speed. It's a little smaller or bigger than the tennis ball, but smaller than the basketball. So that's my project. All of those things have to do with geometry because of the field and the strike zone. So that's my project. Love the Cubs. Bye.